Welcome to Oryx Learning. Today's lesson is Unit 2, Equations in One Variable, Lesson 4, Solve Two-Sided Equations. Which is the best deal? Tamir is comparing two streaming services that feature his favorite show. He was wondering which service was the best deal. One service charges a $50 setup fee and then $12.50 every month. Another service charges $62 for a setup fee, but only $10.50 every month. Tamir set up a table to determine what the total cost of each service would be for several different months. As you can see in the chart, at 4 months, service A would be $100 and service B would be $104. When we get to 6 months, service A and B are both $125. And then when we get to 8 months, service A is now more expensive at $150 compared to service B at $146. So Tamir notices that for the first 5 months, streaming services for service A is the best deal. At the 6th month, the cost is the same, but after that, the streaming service B becomes the best deal. We can also solve Tamir's problem by solving a two-sided equation. The two streaming service prices can be written as an algebraic equation. To find when the two services cost the same, set the equations equal to each other and solve. We can let m equal the number of months. So the initial setup fee plus the monthly cost times the number of months would be 50 plus 1250 times m equals 62 plus 1050 times m. So service A equals service B. Combining our like terms, we can take the inverse of addition, which is subtraction. So subtract 1050 from both sides. That will give us 50 plus 2m equals 62. Subtract the 50 from both sides of the equation, and we'll get 2m equals 12. And the opposite, or the inverse of multiplication, is division. So we can divide both sides by 2, and that leaves us with m equal to 6. 3 steps to solving. The first step is to gather the variable terms together on one side of the equal sign by adding or subtracting. Second, isolate the variable term by adding or subtracting the constant. Third, isolate the variable by multiplying or dividing by the coefficient. Is the given value a solution? If we want to test if v equals -8 is a solution to the equation 1/8 v plus 3 equals 3/4 v plus 13, we can substitute in a -8 for v because v is equal to -8. After that, we will simply need to simplify both sides of the equation. So 1/8 times -8 will give us -1, and 3/4 times -8 will give us -6. That will leave us with -1 plus 3 equals -6 plus 13. Well, -1 plus 3 is 2. -6 plus 13 is 7. 2 does not equal 7. Therefore, -8 is not a solution to the given equation. What equation is modeled below? So here we're using our algebra tiles. We can see with the red rectangles, we have 3 of the negative x's. We have 6 of the 1's that are represented with the yellow squares. And it's equal to 1 of the x rectangles, the green rectangle with an x, and 2 of the -1 squares. So if I combine these together, -x plus -x plus -x is -3x's. The 1's, if I combine them together, 6 1's gives me 6. On the other side, I have the one green rectangle that's represented by x, and a -1 and a -1, which gives me -2. So negative 3x plus 6 equals x minus 2. Solve for the variable. 5r minus 4 equals 2r plus 5. So our first step is to gather the variable terms to one side of the equation by using inverse operations. So in this case, I'm going to take the 2r to the other side of the equation using the inverse of addition, which is subtraction. So I will subtract 2r from both sides of the equation. 5r minus 2r leaves me with 3r. So we have 3r minus 4 equals 5. My second step is to isolate the variable term by eliminating the constant using inverse operations. So the inverse operation of subtraction is addition. So I'll add 4 to both sides of the equation. This leaves me with 3r equals 5 plus 4, which is 9. And then my third step, isolate the variable by eliminating the coefficient using inverse operations. So the inverse of multiplication is division, so I can divide both sides of the equation by 3. That leaves me with my variable isolated, r equals 9 divided by 3, which is 3. Solve for the variable. So this one we have 2/3 b minus 4 equals 1/5 b plus 7. My first step, gather the variable terms to one side of the equation by using inverse operations. So I'm going to subtract the opposite, or the inverse of addition, subtract 1/5 b from both sides. 2/3 b minus 1/5 b, right? Remember we need a common denominator. So the common denominator between 3 and 5 is 15. If the first fraction gets multiplied by 5 in the denominator, it will get multiplied by 5 in the numerator, creating 10/15 b. The second fraction got multiplied by 3 in the denominator, so we'll multiply by 3 in the numerator and get -3/15 b. So now I have 10/15 b minus 3/15 b, which leaves me with 7/15 b, and I still have the minus 4 equals 7. My second step will be to isolate the variable term by eliminating the constant using inverse operations. So the inverse of subtraction is addition, so I can add 4 to both sides, leaving me with 7/15 b equals 7 plus 4, which is 11. And then my last step is to isolate the variable by eliminating the coefficient using inverse operations. So the inverse of multiplication is division, so I can divide by 7/15, which is the same as multiplying by the reciprocal, that multiplicative inverse. So I can multiply both sides of the equation by 15/7, leaving me with 165/7, or as a mixed number, 23 4/7. Our next example, we have Omar wants to know the area of his patios. He knows the perimeter is the same as they are required the same amount of edging. The length of the front patio is 2 meters less than twice its width. The back patio is 2 meters wider than the front patio. The length of this patio is 2 meters longer than its width. What is the area of the patios? So first we can let W equal the width of the front patio. The length of the front patio is 2 meters less than twice its width. So the length of the front patio is 2W minus 2. The perimeter of a patio or a rectangle is 2L plus 2W. So the perimeter of the front patio is 2L plus 2W. And if we substitute in our values, the perimeter becomes 2 times the quantity 2W minus 2 plus 2W. If we distribute the 2 times 2 is 4, so we get 4W minus 4 plus 2W. Combine our like terms, 4W plus 2W gives me 6W minus 4 as our perimeter. The width of the back patio is 2 meters wider than the front patio. So the width of the back patio is W plus 2. The length of the back patio is 2 meters longer than its width, making the length of the back patio W plus 2 plus 2, or W plus 4. The perimeter of the back patio, 2L plus 2W, substituting in our values, will give us P equals 2 times the quantity W plus 2 times the quantity W plus 4. Distribute the 2 in both, and we'll get P equals 2W plus 4 plus 2W plus 8. We can combine our like terms. 2W plus 2W will give us 4W. 4 plus 8 is 12. So the perimeter of the back patio is 4W plus 12. Right, now I can set the two perimeters equal. So I have 6W minus 4 equals 4W plus 12. I can get my variables on the same side by taking the inverse of addition. So I'll subtract 4W from both sides of the equation, leaving me with 2W minus 4 equals 12. The inverse of subtraction is addition, so I can add 4 to both sides. So 12 plus 4 is 16. And then the inverse of multiplication is division, so I can divide both sides by 2 to isolate the variable. So W equals 16 divided by 2, or 8. Right, so if the width of the front patio is 8, then the length is 2 times 8 minus 2, so 16 minus 2, which is 14, which gives me an area, length times width, of 8 times 14, which is 112 square meters. If I put the 8 into the width of the back patio, 8 plus 2 is 10, so the width of the back patio is 10. Substituting 8 into the length of the back patio, I get 8 plus 4, which is 12. The area, again, length times width, 10 times 12, is 120 square meters. So the area of the front patio is 112 square meters. The area of the back patio is 120 square meters. All right, so to review, we have 3 steps to solving equations with variables on both sides of the equal sign. First, we need to gather the variable terms together on one side of the equal sign by adding or subtracting. Second, isolate the variable term by adding or subtracting the constant. And third, isolate the variable by multiplying or dividing by the coefficient. That is our lesson for today. We hope you enjoyed. Thank you.